Hi, I'm Weiwei. This video is for introducing for the K-means clustering for chapter 3. So it is an option video. So for in this video, we will introduce the detail about what is the K-means and what the step of the K-means clustering. So the first step is to present the data which need to cluster. We generate some data in this picture, and all of the step has been visualized through our codes. That means we write all of the codes to visualize all the process of the k-means clustering. Okay, and all of the codes is provided in codes library, and it is this file. Let's back to introduce the k-means cluster. This data point, it is not the data set provided. It is just generated by us and just to use to help us for introducing the k-means clustering. Okay, so the step 1, we generate some point in U. After that, we need randomly select k-cluster centers. If we like to divide it all the data points to two parts, we need set to k is 2. If we like to divide it all the data points to 5 parts, we need set k is 5, and so on. So in this case, we would like to divide it, the data point to two parts. So we set k is 2 and select two position for the cluster centers randomly. Like this figure, the red point is generated randomly. Once we have generated the cluster centers, we have the initial cluster centers. After this step, we will enter to step 3. And step 3 is for calculate the Euclidean distance for each point to each cluster centers. For example, for this data point, we need to calculate the distance to this cluster center. Besides, we need to calculate the distance from this data point from another cluster centers. Because for the next step, we need to compare the distance between these. And which distance will more short, we will assign the data point to which cluster center. For example, this distance is more short than that distance, so we divided this data point to this part at this time. Besides, for this step, we need to calculate the distance from each point to each cluster center. That means we need to calculate like this figure. Once we have calculated all of the distance, we can enter to the next step, step 4. The step 4 is compare the distance and assign the point to the closer center. For example, this data point which with the black color, it is closer to this cluster center, so we divided this data point to this cluster center at the first. Besides, the data point which with the yellow color is more closer to this cluster center, so we divided this data point which with a yellow color to this part at this time. However, this is not the final cluster results because the cluster center is chosen randomly at initial, so it is not accuracy. So we need to do the next step and update the center to the centroids. Let's enter the step 5. As we mentioned above, this cluster center is not accuracy. So what is the more accuracy position for the cluster center? We use the centroids. For example, all of the data point which with the black color is one part. However, what is the cluster center for this part? We think the most suitable position is the centroids of all of the data points which with the black color, so that we can calculate the centroids of all of the data points which with a black color and define this position is the new cluster center. After that, we need update the old cluster center to the new position. For each part, we do the same task. For example, for this part, which the data point with the yellow color, we calculate the central is in this position, so we update the cluster center to this position at this time. So that we could find through the step above, we could regulate our cluster center more and more accuracy. That means if we repeat the process of calculate distance, assignment step, and update step, we could regulate our cluster results more and more accuracy. The step 6 is to repeat the process of calculate distance, assignment step, and update step until the cluster center no longer changes. As can be seen through this figure, we calculate the distance from each data point to the cluster center. Note that the cluster center is the new position cluster center. It is not old one because we need to make it more and more accuracy. After that, we could repeat the assignment step and repeat the updating step. We just need to repeat this task until the cluster center no longer changes. If the cluster center no longer changes, what does it mean? Means it is the most suitable results for this time. Okay, if the cluster center no longer changes, we could stop the task because it is finished. The result is the final results, and it is also the most suitable results in this situation. Okay, this is the k-means clustering. We use the visualization techniques to present all of the process of the k-means clustering so that we can understand how does the k-means clustering work directly. In the next part of the report, we will use k-means to cluster the dog breed dataset. Okay, this video is just for introducing what is the k-means. Thank you very much for your listening.